Alright, good morning everybody. I'm excited to be back with another installment of Physics with Portals. It's been a while and today's demonstration is going to be all about Newton's 3 laws of motion. This video goes out to Nathan Manderfield, a 4th grade teacher in Bermuda Dunes, California, whose students will soon be learning all about Newton's laws. Let's go ahead and get started with Newton's first law. Newton's first law basically says that objects that are moving will keep moving and objects that are sitting still will keep sitting still until some type of action or some type of outside force happens. This may sound kind of complex, but it's actually something that's very, very simple. We can see an example of it right in front of us. This cube that's sitting still is sitting still, and we don't expect it to all of a sudden start moving for no reason. There's got to be a reason that it starts moving, and that is an example of Newton's first law. We can be that reason. Let's go ahead and bump it. So we walk up against the cube, we bump it, and the cube starts sliding. That cube would never have started sliding, its motion never would have changed until something happened to it. We just happened to be that something that happened to it. Alright, let's look at another example. We can see a cube sitting up here in this cube dropper high above the ground. That cube sitting still is going to keep sitting still until something happens to it. In this case, that something is going to be gravity. We're going to press a button, the cube dropper is going to open, and the cube is going to start falling. That, of course, seems pretty obvious, but let's think about that a little bit deeper. Why does the cube start moving? There's got to be a reason. In this case, the reason is gravity. Gravity is pulling the cube towards the ground. Okay, so let's go ahead and see that in action. I'm going to drop back down here, press the button, and we can see the cube fall, and then slide across the floor. So there are at least two examples of Newton's first law here. The cube falling is an example of an outside force acting on the cube to cause it to start moving, and we can see the cube sliding along the floor. As the cube's sliding, it's not getting any faster or slower, and it's not changing direction. That's an example of Newton's first law. It's an object in motion, and it's staying in motion. It's keeping its same motion until something else happens to it. In this case, that something else is the force of gravity pulling the cube into the pit. Very, very cool. Okay, let's jump ahead to Newton's third law. We're skipping the second one for now, but don't worry, we'll come back to it. Newton's third law says that every action has an equal and opposite reaction. This is used in rockets, it's used all over in physics, and today we're going to see an example of it when we launch this cube against a wall. So we have a cube dropper, we have an aerial faceplate, and we have a wall. We're going to press this button to our left, the cube is going to fall, it's going to hit the aerial faceplate and then bounce off the wall. Let's pay attention to that bouncing action, that cube hitting the wall and then bouncing backwards. In this case, the action is the cube hitting the wall, pushing on the wall, but the wall also pushes back on the cube. It has to, according to Newton's third law. There's got to be a reaction. So the action is hitting the wall, the reaction is the cube flying backwards because the wall pushed back on the cube. Let's go ahead and take a look. So we press the button, cube drops, hits the wall, and then bounces backwards. It doesn't bounce back that far, and there can be other factors that determine how far back it bounces, but nevertheless, it did bounce back, and that is all because the wall pushed back on the cube. If the wall didn't, the cube would have gone right through the wall. Very cool. Alright, let's go to Newton's second law. Alright, Newton's second law, which we're doing now, is a little bit more mathematical in nature. And Newton's second law says that force is proportional to mass and acceleration, or F equals ma. M is of course mass, A is acceleration, and F is force. This gives us some math to work with so we can start calculating forces. In front of us now we have orange gel, or propulsion gel. Propulsion gel causes us to run faster than we normally would. Now when we run, our legs are actually our force. Our legs are the outside action. We push down on the ground pushes back on us, and that's Newton's third law in action. We can calculate that force. So let's go ahead and start running. You can see we get faster and faster, and we launch ourselves up onto this ledge. Okay, so let's see if we can figure out how much force was applied to us, or how much force had to happen to us in order to accelerate us to the right velocity to hop up onto this ledge. So we know that force is equal to mass times acceleration. Our mass, according to the game, is 85 kilograms. And I did this before, and I'll be happy to explain in the comments. Our acceleration from the propulsion gel is 12 meters per second squared. Multiplying the two together, we get 1,020 newtons. That's right, the unit of force is a newton, and that's not an accident. Newton is all about forces, so of course forces are all about newtons. Okay, very cool, very fun, and these are just a few simple ways of showing Newton's laws within the world of Portal 2. There are many, many, many more examples because Newton's laws literally govern how everything moves. It's pretty amazing. Alright, and that's going to be it for today. If you guys have any questions, comments, or concerns, please don't hesitate to post them, and I look forward to seeing everybody again. Take care.